A Spanish research team has obtained measurements for the innermost region of a disk of matter in orbital motion around a supermassive black hole in the quasar known as Einstein's cross. It constitutes the most precise set of measurements achieved to date for such a small and distant object. Typically, astronomers can only detect bright objects that emit a lot of light, or large objects blocking background light. Microlensing is used to study objects that emit little or no light, or are too far away to be detected any other way. Light traveling from the distant object bends around other objects lying directly between it and the observer, redirected by their gravitational fields. This leads to distorted, brightened and magnified images of the distant object which, when studied over time, can be reconciled to give a more complete picture. The object in the foreground essentially acts as a kind of lens, magnifying our view of very distant objects, like quasars, and regions within them. Quasars are very small, very distant objects that emit vast amounts of light. Their energy comes from mass falling onto the accretion disk, a disk of matter swirling extremely fast around a massive central body, in the case of quasars, around a supermassive black hole. Accretion disk is comparable to the size of our solar system, but it is so far away that it has only been possible to measure its structure via microlensing. By studying the variation in brightness of the four different images of the disk, the 4 points of the cross, provided by Ogle and Glittby gravitational microlensing projects, which have had their lenses trained on Einstein's cross for over a decade, researchers have been able to obtain precise measurements of a structure at its innermost region, right at the edge of the black hole event horizon.